All right, welcome to 1-3 linear equations in two variables. So we'll jump right in here. Probably the most familiar equation in two variables that we have is our slope-intercept equation of y equals mx plus b. All right, this is a linear equation. Linear because it makes a line, right? A couple important points on here. We have our m, which is our slope, right, which is rise over run. And we have the point here that we cross the y-axis, which is our y-intercept, otherwise known as b. All right, so those are labeled here. Should be familiar to you from Algebra 1 and 2 and probably geometry as well. So hopefully slope is familiar, rise over run. And we also have another way to say m. Let me just put that in before we move on. Remember that m is y2 minus y1 over x2 minus x1. Another way to say it is the change in y over the change in x. All right? So let's go right in here. Let's sketch the graph of each linear equation, and we'll do it all on one graph. How about? So let's see. The first one, y equals 2x plus 1. My intercept is 1, so I'm going to go up 1. And I'm going to make a dot. And from there, my slope is 2 over 1. So I'm going to go up 2 and right 1 from that red dot. So from the red dot, I'm going to climb up 2. And I'm going to go right 1 and end up right here. And we can connect those two dots to get the sketch of our line. Second one, y equals 2. All right, so this is the same as saying, let's use this as saying 0x plus 2. All right, so my y-intercept is 2. I'm going to go up there, press the dot at 2, and then I rise 0 and run 1. So I go up 0 and over 1. I end up with a horizontal line. All right, so horizontal line. Anytime you have y equals a number, that's going to be horizontal. Anytime you have x equals some number, that's going to be a vertical line. No slope at all on that. Slope's undefined. All right, last one here. Let's do this in blue. You want to get y by itself, so minus the x, y equals negative x plus 2. All right, my y-intercept again is 2, but in this case, I'm going to go down 1 and right 1. So down 1, right 1, and here we are. Negative slope, we're going down. So 3 different options there. All right, see if you can do it on your own with exercise 17. Let me move this out of the way for you. Exercise 17. All right, so just a reminder, we've said this already. We have a slope, and we can find that by subtracting the 2 points, y's over x's. Just a reminder, x's can't equal each other. If they do, it's a vertical line, and you don't have a slope. Slope is undefined for a vertical line. If you have this situation, your rise is infinite, and your run is 0, and you can't divide by 0, so it's undefined for a vertical line. Okay, so let's find the slope of these points here. So let's start with A. All right, negative 2, comma 0, 3, comma 1. We do y's on top, so I'm going to say 1 minus 0 over 3 minus negative 2. You get 1/5 is our slope. For B, let's subtract our y's. 2 minus 2 over 2 minus negative 1. I get 0 over, doesn't really matter what happens on the bottom as long as it's not 0. Turns out to be 3, so I have a slope of 0 for B. Problem C, I've got 4 minus negative 1 over 0 minus 1. And I end up with 5 over negative 1 or negative 5. Notice on this one that I decided to start with the first one first. that's fine. I did that because I thought it might be easier than going -1 minus 4. I don't know, it's pretty much the same. But I just decided I didn't want to start with the negative. But the order doesn't matter as long as if I start with the 4 for the y's, I start with the 0 for the x's. Just make sure the ordered pairs line up. All right, so let's do that down here as well. 4 minus 1 over 3 minus 3. You've got 3 over 0, and so this is undefined for your slope. Cannot divide by 0. Okay, undefined slope, so that's a vertical line, straight up and down. Which one of these, quick check, mental check, which one of these, A, B, C, or D, is a horizontal line? Horizontal line. If you said B, you are correct. Give yourself a pat on the back. All right, try that one for yourself. Exercise 31. Okay, so we have slope-intercept, which is y equals mx plus b. Equation number 2, this is point slope, and this is very helpful if you have a point to deal with instead of an intercept. All right, so y minus y1 equals m times the quantity x minus x1. So dealing with that, let's find the slope-intercept form of the equation that has a slope of 3, m equals 3, and it passes through 1, negative 2. All right, so I know my equation is y minus y1 equals mx minus x1. So let's plug this in. My y1 is 1. My slope is 3. And my, my y1 is negative 2. And my x1 is 1. So this is y plus 2 equals 3x minus 3. And the problem did say, give me slope-intercept. So that means get y by itself. So let's subtract 2 away and get y equals 3x minus 5. Okay? So we're just plugging into that equation, point slope. Try 51. All right, let's remember what we know about parallel and perpendicular lines. Parallel lines never touch each other. And the reason that they don't ever touch each other is because they have the same slope. M1 and M1, exact same slopes as each other, right? If you say M2, then they're going to be equal to each other. All right? And so then perpendicular lines form a right angle to each other. And so to do that, whatever your slope is, this is 5 positive, so this has got to be a negative because the slope's going down. And it's the reciprocal. So opposite reciprocals are the key here for a perpendicular slope. So let's use that. Find the slope-intercept forms of the equations of lines that pass through this point and are parallel and perpendicular to this equation, 2x minus 3y equals 5. All right, so I really need to find the slope of this original equation. Right? So let's do that first. I'm going to subtract this away and divide by negative 3. And I end up with y equals 2/3 x minus 5/3. Don't really care about u because I really care about the slope of the original line. Right? Now I know that m equals 2/3. The slope is 2/3. Let's find some equations. I'm going to go ahead and erase this for space. Let's find the equations of the lines that go through that point that have this slope. So that would be parallel. If I'm parallel, I go y minus y1, negative 1, equals m. Since I'm parallel, I'm going to have the exact same slope as this line. This line here has a slope of 2/3, so my new line has a slope of 2/3. X minus 2. Let's clean it up because I want slope-intercept. Y plus 1 equals 2/3 x minus 4/3. And let's subtract 1. So y equals 2/3 x minus, I'm going to change this into thirds so it's easier to subtract, 7/3. That's the equation of the line parallel. Okay? Let's talk about the line that's perpendicular. So same setup. Y plus 1 equals x minus 2. The only thing that changes is I'm going to use the opposite and reciprocal slope. So negative 3 over 2. Okay, that's the only thing that changes. Let's go ahead and solve from there. Y plus 1 equals negative 3 halves x plus 3. 2's cancel out, and so we'll minus 1, and we'll get y equals negative 3 halves x plus 2. And this is our perpendicular equation. All right, see if that makes sense for you. See if you can do problem 87. All right, moving into our application. So that's it. That's the key to what we're going to learn this chapter. Now let's see if we can actually apply it. All right, so real life problems, they typically don't give you an equation that's already in slope. All right, we're going to have to figure out what's our rise, what's our run, right? So we talk about these in things called either ratios, rate of change, rates, things like that. All right. So let's figure this out. The maximum recommended slope of a wheelchair ramp is 1/12, right? So that's a rise of 1 foot for every 12 feet of run, which makes sense. Doesn't make sense, but seems reasonable. A business is installing a wheelchair ramp that rises 22 inches over a horizontal length of 24 feet. Is the ramp steeper than recommended? All right, so let's convert this and make sure that we're okay. We can either make it all feet or all inches. And let's make it all inches here. So our slope is a rise of 22 over a run of 24 feet. So to convert to inches, I need to times by 12 here. All right, so it's 22 over 24 times 12. And let's see, 24 times 12 is double 12 times 12, so 144 times 2, so 288. All right, so now I'm seeing both even, so 11 over 144, okay? And can I go any further than that? I don't believe so. And we need to make sure that this is smaller than 1 over 12. All right, so we would multiply both of these by 12 to get a common denominator. Is 11 over 144 smaller than 12 over 144? Just barely. So our ramp is kosher. It's going to work. Okay? See if you can use similar thinking for exercise 115. All right, so slope as a rate of change. A kitchen appliance manufacturing company determines the total costs of producing a blender is 25x plus 3,500. Describe the practical significance of the y-intercept and the slope. What we're talking about here are fixed and changing costs. What this is saying is the 3,500 is fixed. It's a fixed cost. So these are things like startup, paying rent, paying employees, so salaries, right? $3,500 is what this company is paying even if it doesn't make a single blender, right? And then, in addition to that, is it needs to pay $25 per blender. All right, so we have two things going on here. The y-intercept is our fixed costs. The slope is our per unit price. And that's going to come up a lot in word problems. All right, so use the same thinking on exercise 119. All right, let's look at this example 7. A college purchased exercise equipment worth 12 grand for the new campus. The equipment is a useful life of 8 years, and the salvage value at the end of 8 years is $2,000. Okay, so this happens. This is like buying a car. When you buy a car for $12,000, 8 years later, you don't get to sell it for $12,000. Okay, in this example, the exercise equipment after 8 years is only going to be worth $2,000. Okay, Depreciation means how much is our item losing value every single year, right? So if it's constant, which in a lot of cases that's true, right? Depreciation becomes straight line, meaning that it's a linear equation. Every single year we lose the same amount of money, right? So we need to figure out what our change in value is over the course of the life of this equipment. So this is similar to rise over run, right? Change in value over the change in years. So this is $10,000 we've lost. I guess I should put these in the other order. This really should be flipped, right? 2,000 minus 12,000, because we've lost money here over 8, right? And so if we're going to divide that, let's see how many times does this go in 1,250 is our slope, okay? And so then we can write a linear equation for this, and we know our slope, negative 1250x. What's our y-intercept? Well, remember the y-intercept is the value at when x is 0, right? X is 0. That's the value when we started, the value when years was 0. So what's our value at the beginning? Well, it was worth $12,000 when we started. Right? So we can plug the y-intercept right in. And that would be the equation for our straight line depreciation for this exercise equipment. Try 121. All right, let's predict some sales here. Best Buy sold approximately 35.9 billion. That's a billion with a B. Okay, good business to be in. In 2006, 40 billion in 2007. Using only this information, let's write a linear equation and predict the sales for 2010. All right, so we're finding slope first things first. So our change, we went from 240 from 35.9 in the course of 1 year, 2007 from 2006. That's a change of 4.1 billion over 1 year, so that's our slope. And so let's go ahead and plug this in, and we can do this 2 different ways. We can say that x equals 0 in 2006. It's probably the easiest way to do it. Or we can say 2006 is our x. Okay? Definitely want to go this route. Pick some year to make x equals 0. Because if you do that, then we already have our y-intercept. Y equals 4.1x plus, how much did we sell in 2006? 35.9. But we need to say that x equals 0 in 2006. Right? So we know where our starting point is. So let's predict the sales for 2010. So y is our sales. E equals 4.1. 2010 is how many years from 2006? That's 4 years later. So we can plug in a 4. And so we've got 16.4 plus 35.9. That's 36.3, 46.3, 50.3 in 2010. Same logic applies for problem 129. Give it a shot. All right, so that's it for all of the equations. Just a quick summary here at the end of the different equations that you have. The only one we didn't really talk about here is the general form, and sometimes problems will either give or ask for your answer to be in general form. What that is get everything to one side, 0 on the other side, and no fractions, right? So it's the simplified version, ax plus by plus c. And that's useful in some applications. We'll use it sometime in the future. So don't worry about it too much for now. Just have that down in your bag of tricks, and any questions, ask me in class or come see me in the math office. Okay, good luck.